Alright, this is Pre-Calculus or AP Calculus, ABA, Unit 4, Lesson 1. We're actually now getting to the formal definition of a derivative. This is one of the two major hearts of calculus. The derivative is one, and the second is the antiderivative or the integral. We'll cover the integral or antiderivative second semester. First semester is all about differentiation, or we call it differential calculus. The calculus of rate of change, so to speak. So let's get into it here. There are two definitions you're responsible for knowing in this lesson. The definition of a derivative is given as f prime of x, okay, which is also the same as d over dx of f of x, or of y, right? So we can refer to it as y. The first is Leibniz's notation. The second is derivative of Newton's notation. But this is the derivative, the instantaneous slope, so to speak, is given as f of x plus h minus f of x over f over h. But there's one thing I forgot to put in, and that is the limit as h approaches 0. This is the primary definition, the one that you will most often see and most often use, the limit as h goes to 0. Okay. The alternative definition is this, okay, f prime of x equals the limit as x approaches c, right? Not as h approaches 0, but as x approaches c of f of x minus f of c over x minus c. Okay. We use the first because it's more readily found. Not every function works for the alternative definition, but they're really different forms of the same thing. Let me demonstrate for you. So let's say we have some curve, okay, f of x, okay, and we've got some point on the curve that we're trying to find the slope at. Some point, in this case, we'll call this x, right? If we go to the right by h units, we add h to x and get x plus h. We get an output over here. Okay? The output of x, when we input x, is f of x. The output when we input x plus h is f of x plus h. Okay? And so you understand the idea of the slope of the secant is this. The slope is the change in y, f of x plus h, minus f of x, over the change in x, which is h. Well, x plus h minus x, the x's cancel out, which is h. So the rise is f of x plus h minus f of x, the run is h, right? And then we take the limit as h as the space between the 2 points drops down to 0. So this point over here is moving closer and closer to the first point. Okay, and I demonstrated that kind of in my last video as well. All right? In this particular case, in the alternative definition, it's really pretty much the same scenario. We have some function f of x, and we're finding the slope, the instantaneous slope at some point we'll call x. Okay, and actually in this case we're finding the slope at a point called c. Okay, and we're going to take some other point, some point other than c, x not equal to c. And that's really important. X does not equal c. Okay. Some point x, and we let x go closer and closer and closer to c. Right? The output of c, if I input c, is f of c. The output of x, if I input x, is f of x. And again, the slope of the secant line, rise over run, if you like, change in y over change in x, is f of x minus f of c over x minus c. Okay, right? So really two different models of the same thing. Now I will mention there is another third option that can come up. I have seen it on the AP test, and that's this definition. So you can call it the alternate to the alternate. It's the limit as h approaches 0 of f of x plus h minus f of x minus h. It's called the double-sided limit over 2h. Okay, and that's built on this. So we have some function f of x. Okay, we have some value that we're looking at, some value x. Okay, and what we're going to do is we're going to go to the left h. So we're going to take away h, x minus h, and input that. And we're going to go to the right h as well, and we're going to input that. And so this is x plus h. Okay, and we're going to take the output, which is f of x plus h, and the output of this one, f of x minus h. Notice we're not even concerned with what f of x is, right? Which is kind of important to know. So we're finding the secant of between these 2 points. And the rise is f of x plus h minus f of x minus h all over, and you can see we went h to the right and h to the left, so 2h. Okay. All right, so let's take an example, a specific example, and apply it. Okay. And I'm going to try it using the alternate definition, and I'm going to show you the trouble we have with the alternate definition. The alternate definition that they give you a very specific example in the lesson because they give you a specific example that happens to factor and cancel. That's a very rare circumstance that you can get a polygon that cancels like that. So let's say my function is x cubed. Okay, it's a somewhat interesting one. And I'm interested in the instantaneous slope. The instantaneous slope at x equals 0.5. So 0.5 is what I'm interested in. Okay? So by definition here, and we can do this in general as well. Well, let's use the standard definition. We're going to solve it generally, not for the specific case, but I'm going to use it to find the specific case. Okay, so I'm going to say f prime of x equals, let's just write the definition, f of the limit, always forget to write the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, and now let's plug that in. F prime of x equals the limit as h approaches 0. F of x plus h is x plus h cubed minus x cubed over h. Okay, and I'm going to forego writing the beginning stuff here, and I'm just going to do some algebra here. So we're going to cube. I can do this in one step. You're familiar with binomial distributions, maybe, perhaps. If it comes to it, you can do this by hand. X plus h times x plus h times x plus h. Okay, and multiply these two, and then multiply the binomial by the trinomial by distributing and combining like terms. But I can use the binomial theorem to do it in one step. So it's 1x cubed. It's 3x squared h. It's 3x h squared, and it's h cubed. And then we'll go minus x cubed all over h. Okay, and again, I'll put in the preliminary stuff here in a little bit. All right, so now minus x cubed and x cubed. And this is a really important step. If this cancellation doesn't occur, this is unsolvable. Okay? But we end up with 3 x squared h. Okay, I'm going to, I'm just going to leave it like that here. I'm going to factor out an h. Factor out an h out of the top. So h leaves 3x squared. And 3 plus 3xh plus h squared. Just factoring an h out of the terms that are left. And divided by h. The h's cancel. I could have done this in a single step, right? And all that's left is 3x squared plus 3xh plus h squared. Okay, now let's put all that limit stuff back in here. F prime of x equals, the limit as h approaches 0. So there, saves a lot of writing. Don't you wish you could do this on your paper? That would be nice. Okay, so we're going to take the limit as h approaches 0 of 3x squared plus 3xh plus h squared, right? And technically we need a parentheses here. Okay, all the h terms are going to go to 0, and notice we've canceled the h on the bottom, so we don't need to worry about. Do worry about this. You can't let h actually equal 0, because then that would result in an indeterminate solution. But this goes to 0. This goes to 0. All that's left is 3x squared. 3x squared doesn't care what h is, so it is 3x squared. Okay. And so what we're saying here is f prime of x is 3x squared, which is a general term, general definition that I can use, that I can now use to find any derivative. So the instantaneous derivative at 0.5 is 3 times 0.5 squared, which is 3 times 0.25, which is 0.75. Okay. Right? All right. So that's how to use the general definition. The specific definition would be probably impossible to do in this particular case. Let's do it, though, just to see how it's set up. So f prime of x, okay, equals the limit as x approaches c of f of c, or f of x minus f of c, all over x minus c. Okay, so just to set this up, f prime of x equals the limit as x approaches c of f of x, which is x cubed, minus c cubed over x minus c. And the only way this is going to possibly work is if the top factors to make the bottom. Now there is a pattern called a difference of cubes, and I do believe that might simplify here. Let's check here a little bit. Let me do some research. Yeah, I thought there was. So the top does factor, okay, and here's how it factors. And this is kind of interesting. I don't know that it will result in being able to do anything. Okay, here's what I wanted. All right, I wanted to slide this up. Okay, so this factors to x minus c times x squared plus xc. Yeah, x squared plus xc plus c squared. Okay, all over x minus c. And so the x minus c's do cancel, which is very important here. And we're taking the limit as x approaches c. That's the definition of f prime of x. Okay, so now we have x squared plus xc plus c squared, the limit as x approaches c. Okay. F prime of x. Okay, as x approaches c, this becomes c squared plus c squared plus c squared. I love it when something works that you didn't necessarily anticipate. But it happens to be because we happen to know the pattern for factoring and difference of cubes. All right? What is c squared plus c squared plus c squared but 3c squared? Yay! All right, so that's for f prime of c equals 3c squared. And we're going to let c be 0.5. So it does turn out to be the same as the general definition. But the problem with the special definition is it does require you to be able to factor and cancel. And that doesn't always work. So the primary definition is the one we usually go with. All right, hopefully that helps.